Hi, everyone. Welcome back. Today we are going to be jumping into 7-1, our first notes in Topic 7. Topic 7 is on polynomials and factoring. This topic, we will be covering adding and subtracting polynomials, multiplying special cases, factoring polynomials, and factoring special cases. In the below graphic here, we've got our one method for multiplying polynomials, and we call this the FOIO method. We'll talk more about that as we get to that, but this is kind of a fun infographic about the middle term here, so we'll talk more about that later. Today we're going to be doing 7-1. If you're following along with me, this is pages 1 and 2 in your notes packet, and this is on adding and subtracting polynomials. Let's start by defining some of the key terms in this chapter. The first is a monomial. A monomial is a polynomial expression that has exactly one term where all the exponents are whole numbers or natural numbers. So whole numbers, they can't be fractions, can't be decimals, and they're positive numbers. So I want to determine which of the following expressions are monomials. The first one we have 12. This is just one term, it's just 12, and the power is 1, 12 to the 1. So this is a monomial. Next, we have 4x plus y. I can see they're two terms separated by addition, so this is not a monomial. We have two terms, not one. For the third one, x squared y to the negative 3, this is a product. This is one single term, so we're good there. However, the power here, I see we have a negative 3 up here. This is not a whole number. This is or not a natural number. We have a negative number, so this is not a monomial. Next up, 2n, another product, where our powers are both 1. So this is, we do have whole number exponents. We do have one term. This is a monomial. Similarly, 5z, again, one term, whole number exponents. This is a monomial. And then last but not least, a, b, c to the eighth, all over 4. This is a monomial. We could think of this as that 4 on the bottom. We can think of this as 1/4 is the coefficient, and then a, b, c to the eighth. Again, positive exponents. It's a product. No adding or subtracting. This is a monomial. I do also want to reiterate one term. That's where we get that prefix, mono. So that's one way we can remember what a monomial is. Now let's talk about the degree of a monomial. The degree of a monomial is the sum of all the exponents of the monomial. So if we take all of the exponents, we can determine the degree. So we're looking at the variables here. So the first one, 5x, well, the exponent of the x is 1. So this polynomial, this monomial, has degree 1. Next up, we have 2a squared bc. Well, the b and the c, they're not written, but we know that the exponent is 1. So the sum of all the exponents, we have 2 plus 1 plus 1 is 4. So this has degree 4. 7 does not have any variables, so this has degree 0. This is a constant term. So we only look at the variables here. Now let's actually define what a polynomial is. Well, you can determine from a monomial that has one term, a polynomial is a monomial or many terms. So poly, meaning many, is like many monomials. Or in other words, a polynomial is a monomial or a sum or difference of monomials. Sum or difference. So we're taking a bunch of monomials and we're adding or subtracting them together. Each of these bits that we add or subtract together are called the terms. So the terms are the parts of the expression that are added or subtracted. An example, if we have 3x plus 8y, we have two terms in this case. We have both 3x and 8y. These two are being added together, so each of these are terms. The degree of a polynomial with a single variable is the highest exponent on any of the terms. Whoop, I forgot an H in there. Highest, there we go. So in order to determine the degree, we take a look at our variables and determine what the highest exponent is. So here we have 5x plus 8. Well, here again, it's not written, but we can assume that the exponent's 1. So this, the highest exponent here is 1. So the degree is 1. For 2a squared plus 9a, the highest exponent is this 2. So we have degree 2. For 7 minus y to the fourth plus 3y, the highest exponent is 4. So this polynomial has degree 4. Now let's talk about standard form of a polynomial. It's good practice to write your polynomials in standard form, so let's go ahead and define what is standard form. A polynomial is in standard form when the terms are written with the degree in order from greatest to least. So I like to say that the powers, or the exponents, are in descending order. So we want to take those powers and write them in descending order. Let's go ahead and classify each of these polynomial expressions by the number of terms and the degree. For the first one, we have just 3. This has one term, therefore it is a monomial. The degree, it's a constant term, there's no variable, is 0. So therefore, I already said it, the name, this is a constant. Next up, 4x. Again, this is just a product of 4 and x. There's no adding or subtracting, so this has one term, a monomial. The degree in this case, we have the x is raised to the first power, so we have a first degree monomial. And we know that this, if we were to graph this, this is a line. Well, this is a linear monomial. So degree 1 is linear. Next up, x plus 8. Here we have a sum of two monomials. So we have x and 8. This is two terms, or a binomial. This has degree, so look at the highest exponent. Highest exponent in this case is 1. And again, this is linear. Again, if you were to graph this, x plus 8, this is in slope-intercept form, y equals mx plus b. This is a line. So you can double check your work that way. Next up, 3x squared plus 2x plus 1. We've got three terms here, 1, 2, 3. So if you're following the pattern, this is a trinomial. Trinomial. The degree, or the highest exponent, is 2 in this case. So this is a quadratic. Next up, number of terms. This is just a product of negative 5, x squared, and y. So this has one term. This is a monomial. The degree is the sum of all of the exponents. So we have x squared, or 2, and y to the first, 1. This has degree 3. And we know that a degree 3 monomial is, or polynomial, is a cubic. So this is a cubic monomial. Next up, number of terms. We've got 1, 2, 3, 4. So we've got 4 terms. And we don't have a special name for 4 or more terms. We just call them polynomials. The degree, the sum of the highest exponents. So we have 2 and 2. This has degree 4. We call this a quartic. And last but not least, number of terms. We've got 1, 2, 3. So this is a trinomial. And the degree, the sum of the exponents. We have 2 and 1. So we have degree 3. So third degree is cubic. We can classify polynomials by the number of terms and the degree. A one-term polynomial is a monomial. Then it goes 2 terms is binomial. 3 terms is trinomial. And 4 or more terms is just polynomial. So if it has 5, 6, 7 terms, just call it a polynomial, or many terms. The degree, if it's a 0 degree, we refer to it as a constant. 1 degree is linear. Degree 2 is a quadratic. Degree 3 is a cubic. Degree 4 is a quartic. Degree 5, which we didn't see, is a quintic. And then anything 6 or greater, you can just call it by that number. So if it's 6, you can call it a 6th degree polynomial or 6th degree monomial, binomial, whatever you have. So you can call it, for 6 or greater, is just the nth degree. Okay. Now let's actually get some practice. So part 2, adding and subtracting polynomials. In order to add or subtract polynomials, we need to combine like terms. So as a review, like terms are terms that have the same variables and the same exponents. So they need to have the same variables and the same exponents. Now remember, if we're having a grouping of polynomials and we're subtracting, remember to distribute that negative. We'll see a few examples now. Let's start with number 1. Here we're adding the two binomials here, each have two terms. And I'm going to look for like terms. So I see that we've got a 3n and a 9n. Those are like terms. And I also see, I'm going to use a different color. I also see we have our constants, positive 5 and negative 2. So when combining like terms, in order to add polynomials, we just combine like terms. So 3 and 9 gives us 12n, and positive 5 and negative 2 gives us positive 3. So when we add these two together, we get 12n plus 3. Next up, we are adding these two polynomials, two trinomials. I see we've got some y squareds. We've got some y terms. And we've got some constant terms. So let's go ahead and combine those like terms. We've got 4y squared and 1y squared gives us 5y squared. We've got 8y and 3y. 8y and 3y gives us 11y. And we've got positive 5 and positive 2, which gives us positive 7. Next up, for number 3, we're subtracting two binomials. So what we're going to do is distribute that negative and make it a positive. So I'm going to rewrite this whole expression here. 10d minus 4. And I'm going to include those parentheses. But now we're going to add and then distribute that negative. So we have negative 2t minus 7. And now we have to identify the like terms. So looking at this, I see we've got 10d. There are no other like terms. So I'm just going to underline that in red. We've also got negative 2t, also no like terms there. However, I do see that our constant terms, whoops, we'll make that blue. I do see that our constant terms, we've got some like terms here. So we've got a negative 4 and a negative 7. So 10d, that just gets carried along. Our negative 2t, that gets carried along. And then our negative 4 and negative 7, we can combine. And that gives us negative 11. And that's it. Number 4, again, we're subtracting. We've got a trinomial minus a binomial. So I'm going to subtract. We're going to distribute that negative. And I'm going to rewrite the problem. So 6a squared plus a plus 5. And then plus, and then distributing the negative, negative 3a. And then negative times negative 1 is positive 1, so plus 1. Some like terms, I see we've got, well, 6a squared. There's no other a squared, so that can't be combined with anything. We've got a 1a, positive 1a, and a negative 3a. And our constants, we've got a positive 5 and a positive 1. So rewriting and combining like terms, we have 6a squared. A positive 1a and a negative 3a gives us a negative 2a. And a positive 5 and a positive 1 gives us positive 6. All right, a couple more for today. Let's find the perimeter of the rectangle. Now, as a reminder, the perimeter of a rectangle is the sum of each of the sides. So I'm going to go ahead and write out these side lengths here that are missing. I know that the sides opposite are congruent. So we have x squared plus 7x plus 11 on this length. And then on the opposite width, we've got 3x minus eighth. Okay, so now we're going to add up all the sides. So it's the sum of all of the side lengths. So adding up the sides, we'll start by identifying some of these like terms. I see we've got an x squared and an x squared. Adding those up, we get 2x squared. Looking at our x terms, I see we've got a 7x, 7x, 3x, and 3x. So 7 and 3 gives us 20. So plus 20x. And then let's add up our constant terms using a different color. We have a positive 11, negative 8, and negative 8. Adding those up, we get positive 6. And that's our answer. Last one for today, I want to know the leading coefficient of this trinomial here. In order to determine the leading coefficient, you first have to put it into standard form. So as a reminder, standard form is decreasing power order. So I'm going to write out each of these terms in decreasing power order. So the first is going to be this negative x squared. So negative x squared, and then our x terms, so minus 3x. And then we've got a positive 5, so plus 5. So now this is in standard form. Our leading coefficient is that number in front of our first term. So this number in front is a negative or negative 1. All right. So this has been our notes on adding and subtracting polynomials. Go ahead and try the remaining 3 examples on your own and watch the video to check your work. All right, we'll see you tomorrow. Bye, everyone.